Welcome. So in this part of the notes, we're going to go through some special cases. Now, before we read through any of this, let's just look over here. This is what we've seen so far. We've seen situations in which we have unique solutions. What does that mean? So here are our two equations, x plus y is equal to 15, which is represented by this red line here, and 4x plus 2y is equal to 46, which is represented by this blue line here. What we're trying to do is solve for x and y. That's what we're trying to do. And as you can see, there is one unique solution to that, and it's where the two lines intersect. So when x is equal to 8 and y is equal to 7, these two equations are satisfied. So as you can see, there is one unique solution. This right here is one unique, because there's only one of them, solutions. That's what we've seen so far. But would you agree with me that it's possible to have different situations here? The lines don't necessarily have to look like this. So we're now going to see other scenarios, not necessarily a unique solution scenario. So let's come over here and let's do some reading. Okay. So it says, note, when asked how many solutions there are three options. One unique solution, and that's when the determinant is not equal to 0. And that's what we've seen over here. This is this situation here. Let's keep on going. The next one is 0 solution. So that is no solution. And that's when the determinant is equal to 0. Okay, what is that? Let me do some color coding here. All right, so what is this situation right here? Well, let's come here and look at it. So no solution. That is the two graphs of the equations do not intersect. The set of equations is said to be inconsistent. The lines are parallel. So as you can see here, I've got this blue line here, which is represented by this equation, and this red line here, which is represented by this equation. And you see how they never intersect. At no place do they touch. So that means there's no solution to the x and y here. It just never works. All right, let's look at the next one now. We'll grab a green. This is when you have an infinite amount of solutions. So in other words, you have no unique solutions. And this also occurs when the determinant is equal to 0. So let's look over here at this situation. So no unique solution. So that is the two equations are equal and the lines intersect infinitely many points, at infinitely many points. The set of equations is said to be dependent. So as you can see here, we've got these two equations, x minus y is equal to -1 and negative 2x plus 2y is equal to 2. And in actuality, this is the same equation, and therefore they touch each other infinitely many times. So if you've got an infinite amount of solutions, that means you have no unique solutions. So when you have the same line, that means you have no unique solutions here. And if you're asking yourself, these lines look different. This is x minus y is equal to -1, and this is negative 2x plus 2y is equal to 2. How is this the same line? Well, it's the same line because let's examine something for a second. Here is negative 2x, and here is x. Well, if I multiply this, and I'll do this in a different color. What color should I do? I'll do it in orange. If I multiply this x by -2, well, -2 times x is negative 2x. And if I multiply this negative y by -2 as well, well, negative y times -2 is positive 2y. And if I multiply this -1 by -2, well, -1 times -2 is positive 2. So do you see, by doing the same thing to each of these terms, it becomes the same line? And that's because it is the same line. So that's how you've got to recognize dependent things. When you can say, well, I can do the same thing to each of these terms here, and it's going to end up looking exactly the same as the other equation. Therefore, these equations are the same. Okay, so that's just a bit of an introduction to what it means. We're now going to go through these with a bit more detail. You don't have to write any notes for what we're about to do, but that is a nice little summary of the special cases you can have. So you can either have one unique solution, no solutions, that's when they're parallel, or an infinite amount of solutions, so no unique solution, that's when the lines overlap. And all of these occur when the determinant is equal to 0. So this means we cannot solve the simultaneous equations, and these are the two situations in which this occurs. All right, let's pause here for a second, and let's just go through some of these examples a bit more thoroughly.